Okay, moving on. Here we have got the whole idea of the normal distribution. What speed is exceeded by 5% of the drivers? So what we're looking at here is we're trying to find out if that's 0.05. Okay, we want to find out what value's here. Now, if we just scroll up, we can see that our mean was 41.5. So we've got a mean of 41.5, and we've got a standard deviation of, where were we? Oops, 6.8. Okay, so how do we do this? The easiest way is on our calculator. So you get the calculator, menu, stats, execute, distribution, and you go normal distribution, inverse normal, because we've got the probability, but we're wanting to find out what that value is here, that 5% of cars exceed. So the tail's actually to the right. Okay, so we're going to pop it to the right. The area is 0.05 because that's 5%, and 6.8 is our standard deviation, and 41.5 is our mean. So we get 52.6. We're going to round it to 69. So what does that mean? What speed is exceeded by 5% of the cars? Well, 52.7 kilometres per hour is exceeded by 5% of the drivers. The next one is also set up for people with calculators. Very tricky without the calculators. Okay, if you want to do stats next year, you just have to buy a calculator, end of story. So what it's saying here is which two speeds do the middle 50% of cars travel out at? So the middle 50% is in here. And we're looking at what's this and what's this. So this area here is 0.5. So we get our calculator, and this time we just go centre, and our area is 0.5 in the centre, and it spits out 36.9 km to 46.09 kilometres per hour. Okay, so 36.9 kilometres per hour to 46.1 kilometres per hour. Okay, I've been slightly inconsistent with my rounding. I should have rounded that up to 46.1. It's just a rounding thing. So if we give those ranges, we actually get excellence. Okay. If you find one side and not the other, that's really for people with tables. If you've got the graphics calculator, excellence is actually surprisingly easy. Okay, next. A group of students recorded the speed of 75 cars that passed their school one morning when the speed limit was restricted to 40 kilometres an hour. Wow. Some sample statistics in a histogram representing the data are shown below. Okay, makes sense. So we can see the minimum speed is 20, the maximum speed is 54. Okay, we've got a mean and we've got a standard deviation. What proportion of cars travel between 35 and 45? So between 35 and 45, we're actually looking at this column and this column. Okay, between 35 and 40 and 40 and 45 will be between 35 and 45. Now how many is there? We've got 15 plus, how many is here? We've got 20. Okay, so So that's the number of cars going between 35 and 45, but we need to divide it by the number of cars, and they actually told us the number of cars. We don't even have to count them up because they said there was 75 cars. So that's going to be divided by 75. So you can just do it on your calculator and go to run, and you're going bracket 15 plus 20 divide by the total number of cars, and we got 0.47. 47%. Okay. Alright, another thing, you can see that that's 35 upon 75, and that's the same as 7 over 15, because 7 5s are 35 and 15 5s are 75. If you want to divide by 5, you can actually times by 10 and divide by 2. Sorry, dividing by 5 is the same as timesing by 2 and dividing by 10. So 35 and 35 is 70, take a 0 off to get 7. 75 and 75 is 150, take a 0 off to get 15. Anyhow, that's cool. The students think that the speeds of the 75 cars are normally distributed. Are they justified in drawing this conclusion? Okay, so with a normal distribution, your mean, median and mode would be the same, wouldn't it? And here we've got a median of 42, a mean of 40. Okay, so these are not the same. So the median of 42 and the mean of 40.9, they're not the same. So if we look at this, we can sort of see a little bit of a normal distribution, but it's skewed to the left because it just sort of stops here, doesn't it? No one's going faster than that. So it's kind of is, but it's not. Okay, so you have to use statistical terms. So what the answer schedule says is if the data was normally distributed, then the mean and the median would be the same. The histogram would be bell-shaped with a symmetrical distribution. 99% of the cars would have speeds between this and that. Now, how would you work that out? You don't have to work out that figure, but you basically can look within 3 standard deviations either side. So that's what you need to do to get excellence. So you might say 67% of the cars should be between here and here. The histogram shows speeds between 20 and 54 kilometres. The data shown here has a slightly higher median compared to the mean, and the histogram is skewed to the left. Therefore, the data is not normally distributed. Okay, so it looks a little bit normally distributed, but it isn't. Okay, so it's precision to detail. So let's just have a look how we would work that out on our calculator. We go into stats, because you're going to have to do some calculations to get the merit. Go to distribution and go normal distribution. You can go inverse normal, central, and put your 99%, and your standard deviation is 7.6, and your mean is 40.9. Hit execute, and you've got between the 21 and the 60, so 99% of the data between the 21 and the 60, and you can see that somebody was going 20 but no one was going 60, so that's where you get your skewness. Okay, so it's not your standard normal distribution. Does that bring us to the end of this paper? It sure does. So you've got video answers somewhere for the whole lot. Hopefully that helps.